Hello class, today is another asynchronous day, which means I'm going to record this video. Hopefully you're going to watch it, and then you're going to use the knowledge gained from this video to help answer some questions. Today's lesson is going to be lesson 7. We are going to be skipping lesson 6 because we don't really think that it's going to be too necessary for us. Might touch on it a little bit later, but for now we're just going to skip straight on to lesson 7. Lesson 7 is going to be talking about the relationship between our visual fraction models and equations. Now, in order for us to understand what that really means, we need to think back to what we've been doing so far. We've been doing a lot of dividing fractions by other fractions. What we are going to be doing today is we are going to be drawing a model. We are going to be using that model to help us solve the question, and then we are going to be using that model to help explain why, when I divide two fractions, I can change it to being division to multiplication by flipping my second fraction. We're going to help explain why that works using a model. So for example 1, it tells us to model the following using a partitive interpretation. Now, we need to think back and we need to remember what a partitive interpretation means. A partitive interpretation is going to say that 3/4 is 2/5 of what? The reason that this is called partitive is because this 3/4 is going to be a part of a greater whole. How large is that part that it is? It's 2/5 of some new greater whole. So when we're doing a partitive, this is going to be the diagrams that are going to really remind us of a tape diagram. So what I'm going to do is I'm going to take a long bar here, and I'm going to say that this is my whole, and I'm going to split this whole up. How many pieces am I going to split it into? I'm going to split it into 5 pieces because we need to worry about 2/5. So let's split this into 5 separate pieces. So now I have 5 pieces. How many pieces am I worried about? I'm worried about 2 of them. And what size is 2 of them? 2 of these pieces is going to be 3/4. So shade 2 of the 5 sections. We'll do that. Make it a little bit thicker to help me shade it in a little bit better. I've shaded in 2 pieces and labeled the part that is known, aka these 2 pieces. We've labeled that as 3/4. So it's asking us, let's change the thickness back down. It's asking us to make notes below on the math sentences that we need in order to solve this problem. So let's look at this. Let's think, well, what are we going to do first? Well, I know that 2 squares is going to be 3/4. So that means that in order to find 1 square, I need to take my 3/4 and I'm going to need to divide it by 2 because I need to split it into 2 different parts. Well, it's not really so much as splitting it into 2 parts and dividing by 2. Since we're finding half of it, I could also, instead of saying 3/4 divided by 2, I could say 3/4 times 1/2. So I'm splitting it in half, and when I do 3/4 times 1/2, I'm going to get 3/8. So with that, I find that each and every single one of these pieces is going to be 3/8. So that piece is going to be 3/8. This piece is going to be 3/8. This piece is going to be 3/8. This piece is going to be 3/8. And this piece is going to be 3/8. But obviously the question's not done yet, because in order to fully answer the question, I need to find out, well, what's the entire thing? Well, how many pieces do I have? I have 5 of them. So I'm going to take the value of one piece of my 3/8, and to find out how big it is, I'm going to multiply that by 5, because I have 5 total pieces, and each one of those pieces is 3/8. So when I take that and I solve that, I'm going to get 15/8. Or if I wanted to, I could simplify this down to 1 and 7/8. Now, if I wanted to take what I've done here, and as opposed to doing it in 2 steps, do it in 1 step, it would be, I'd take my 3/8, multiply it by 1/2, and then multiply it by 5. Now, quick question that obviously you can't answer because this is a video, but quick question, does order matter when it comes to multiplication? No. Order doesn't matter when it comes to multiplication. I can multiply my 3/4 times 1/2 first. I can multiply my 5 times my 3/4 first. Or what we're actually going to do is I'm going to multiply my 1/2 times 5 first. And that's going to give me 3/4 times 5 halves. Wait a minute. Let's look back up to what we had. We had 3/4 divided by 2/5. And now we have 3/4 times 5 halves. So if we look at what we've done here, I've taken my 2/5 and I've flipped it on its head. And I've changed it from division to multiplication. So what we've done, even though we didn't just say, oh, you just flip it and you multiply, we've proven here by just using this model that our invert and multiply works. This method's official name is, and I'll write it down, the official name of this method is called invert and multiply. The word invert basically means to flip it over up on its head when it comes to the fraction. An inverted fraction is a fraction that's been flipped over on its head. Not multiple, multiply. So, what we are going to do now is, well, let's scroll on down. Let's do this one more time with example 4. For example 2, it's asking us to model the following using a measurement interpretation. So we're going to be, instead of using the partitive interpretation we used above, up here, we're going to use a measurement interpretation. For our measurement interpretation, this is going to be asking us how many 1/4 are in 3/5. This one's going to ask us how many 1/4 are in 3/5. Now, if you remember back, not to last lesson, but the lesson before it, when we were dealing with measurement, the first thing that we wanted to do, and, well, back then they kind of gave us, like denominators, but for this, we want to make our denominators the same. What's the easiest way to make these two denominators the same? Why, it's, well, if I multiply this one by 5, and this one by 4, well, look, this one's going to be 4 times 5, and that one's going to be 4 times 5. So I'm going to get the same denominator. I could do the same thing up here as well, and I'm going to be getting my new question of 12/20 divided by 5/20. And now it's asking us, well, how many 5/20 are in 12/20? Well, there's one big way to find out. That's to draw our model. I need to split this all the way up into 20ths. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Hopefully that should be 20. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. You have 20 of them. And now, well, how many am I going to have to shade in? I need to worry about, at the start, 12 of them. So let's up the thickness just a little bit this time to help us shade in. That's going to be 1. It's going to be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Why did I go so far? Should only be 12. I kept going. I just kept counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We've got 12 now. We don't have 14. We have 12. And what size groups do I need to break them into? Well, I need to break them into groups that have 5/20. Okay. So, let's lower that thickness before we continue any bit. I'm going to have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2. Oh, well, that's our end, but we got to keep going until we get to that group of 5, 3, 4, 5. So I'm going to have 2 full groups. But then my last group only has 2 out of the 5 that it needs. So we get 2 2/5. Now, what if, instead of solving it like this, we sort of checked it with what we had before? That's sort of actually, before anything, we look at it like with our 3/5, and we divide it by 4/1. Not divided by 4/1, multiply it by 4/1. Well, then I'm going to have 12/5. And also the way that we interpreted it before was we just had to, when we had the same denominator, divide across the 5, 12 divided by 5. 12 divided by 5, if I were to simplify, it gives me 2/5. 2 and 2/5. Not 2/5. 12/5 here. 12 divided by 5 is also the same as 12/5. They're both going to give me 2 and 2/5. So, well, we've proven that it's going to work with both measurement interpretation and with partitive interpretation. With partitive interpretation, we actually proved and were able to show exactly why it works, because we multiplied by 1/2 and then multiplied by 5. So, with that, since we have now proven that this is a way to solve it, explicitly proven, what we're going to do is you're going to work on the problem set. You're going to work on our method of invert and multiply in order to help us divide. So invert and multiply, as it's going to even say in this lesson summary right here, is you're going to take your second fraction, you're going to flip it. So C over D becomes D over C. Our division becomes multiplication. I want us to solve questions 1 through 5 for today's classwork. As per usual, if anybody has any questions, send me a message on Schoology. Let me know that you need some help and I can hop onto Teams for you. Other than that, I hope you all have yourself a great rest of your day, and I will see you guys actually tomorrow, because tomorrow we are once again going to be a synchronous class. Thank you all, and farewell.